Hello. It is on. Good. Microphone's active. Output audio. Yes. No. There we go. You were supposed to have music this whole time. The mic is hot. The presenter is hotter. That may very well be a lie. But I do appreciate that. Yeah, you missed last stream. Was kind of nuts. There was a lot of people. You know, I normally do a stream for an hour, maybe 2. And that stream went for 4 hours. Because people kept showing up and asking questions. It was awesome. It's been a hot minute, but you made it. Yep, you're here. You are here. You're live. You're safe, I hope. Guess I should get rid of the stream starting soon thing, huh? Yeah, I'll do that. Oh god, that's the wrong screen! It's alright. Yeah, here we go. I'm in a horrible place, not mentally, just in California. Welcome to chat, folks. Goodness. I don't know, it's probably nicer in Cali right now than it is where we're at, because it snowed. It snowed last night. Actually, it rained heavily from like 9 o'clock till about midnight, and then as it got actually cold enough, it started snowing, so we had like 2 inches of snow in the front yard. You know, good spring weather, question mark? Alright, yeah, we got the planetarium is up. Now I'm gonna do a quick test, just wait and see people showing up, things like that. I'll take snow and rain over politics, government, and the cost of living. The cost of living in California is ridiculous. That is true. I actually tried to get a job at a software company in California. Specifically, they were in Orange County. And I decided to make an Excel spreadsheet because I am a nerd. And that's, well, I was trying to be fiscally responsible. And I, you know, took all of our bills and all of our monthly costs and stuff like that, at least what we have here, you know, set costs, you know, medications and food and stuff like that. And OC is fiscally irresponsible. Yeah, we're getting there. So I did all the math on our end, and like, you know, subscriptions and Netflix and all that kind of stuff. And I made a budget and made some assumptions on, you know, housing costs. I looked around, you know, apartments, things like that. I made some assumptions. And literally to have 0 savings, to break even for my wife, myself, and at the time we only had just the kitty. I would have had to, just if I was the only one working, we would have had, or however it would have worked out, we would have had to make $92,000 to live at the apartment complex I had found and, like, not go into pure debt. It was kind of dumb. That's really expensive for a 1-bedroom apartment. Not gonna happen, man. But I'm glad you're back. Hope you're doing well. Hope the family is well. Looks like, yep, this thing is transmitting pretty well. Just kind of doing some last-minute checks here. We, again, since the weather was weird last night, I noticed, because I haven't really slept. I've been working on some computers as a side thing. The power went out, and I know this computer I rarely, if ever, turn off. And when I woke up, it was off, and it had to do some, you know, Windows is mad at you for turning it off the wrong way kind of thing. The Mac was definitely not happy. And so yeah, I'm kind of doing some pre-flight checks here, because that was unexpected. Nonetheless, let's take a look around. We'll go ahead and start and see how things are filtering. I do see other chats on other areas. That is awesome. Not sure if you know, but we do stream to multiple locations. We stream to Twitch, to Facebook, and to YouTube, all at the same time. So I have like this multi-stream feed coming in. I can see chats from all over the place. I can't necessarily always be able to respond to them in chat, because the multi-stream interface doesn't actually let me do that. But I can talk, so that's also good. So what we're going to do, as we always do, we start out by looking at astronomy picture of the day. Let's see, on Monday we started out with this one, so I'm just going to go through the list. This is a NASA website, always puts up photos and videos of cool astronomy things. This was Mondays, which we talked about extensively because this is a portion of the sky you can see at night right now. This is the area around the constellation Orion. That is Orion to the top right. Kind of weird, though, that they kept this oriented the way it is, because when you go outside, all of this would be turned to the right 90 degrees. Twitch feed is good. Yeah, it's good to hear. Good to hear. So that was Monday. Monday. Here's Tuesday. A stone circle. Something kind of like Stonehenge-ish, I would assume. And again, these are not photos that I put up. These are just photos that NASA puts up every day, something new. If you don't know what it is, there's usually a little paragraph with multiple links at the bottom of them. Today's is this one, Aurora and Lightning on Jupiter. Jupiter does have a massive electrical field around it. It does capture lots of solar wind and particles coming out of the sun. And it will give you the Aurora Borealis, the northern or southern lights, depending on which hemisphere you'd like to talk about. Can we make it bigger? We can make it bigger. Yeah, so there's the Aurora. That's actually pretty cool. Sadly, I've actually never seen the Aurora here on the Earth. I've seen many photos of like Jupiter's auroras and things like that, but I've actually never seen the Aurora of our own planet. Looks like these little splotches over here are lightning strikes in the upper atmosphere. So a lot like you get here, you get lightning in the atmosphere. Again, that's the astronomy picture of the day. Feel free to look it up on your own time. It does go back to 1995 when the pictures were much smaller and lower quality. Hence why it looks like it's an old link website, because that's pretty much what it is. Yeah. Something I'm going to start doing every show, just because I had a lot of questions about it last time, is what software we're using. So obviously we're just using a web browser here. Simple web browser. But we are using Universe Sandbox. You probably saw me playing with this a couple seconds ago. This is something over on Steam that you yourself can purchase for 30 bucks. Actually found out about it a couple months back because a friend of mine said, hey, you should watch this video of Markiplier. He's playing with some sort of astronomy software and blowing up stuff. And I went, hey, that's kind of cool. I think I could actually use it for other things. And I do. I use it for teaching astronomy. So this is over on Steam. Again, you can pick it up yourself. I'm not affiliated with them, nor am I affiliated with this. This is the open source planetarium software called Stellarium. Stellarium.org. It's available for Linux, Mac, Windows. There was a rumor that they were making one for mobile, for cell phones and things like that, but don't know if that ever actually happened or not. But, yeah. That's the software we're going to be using throughout the show. So please feel free to download those and utilize them for your own benefit. Let's switch back to our planetarium software. There we go. So we're going to orient ourselves. The horizon I have gotten rid of. Oh god, that's not what I wanted. We're live. The horizon is represented by the green that you see here. I've gotten rid of all the city lights and all the city structures and any hills and things like that. This is oriented to where I am broadcasting from, our little studio here, Tranquility Lane Studio. And we're in Rio Rancho, New Mexico, so this is the sky the way it looks right now outside. It's actually a lie. It's actually cloudy and really cold and windy, but this would be an idealized version of the sky. We are facing south. We see the sun in the sky. Now, you don't want to stare at the sun. Please do not ever do that. The sun is a star. We're artificially representing the sun here by zooming in. This is not a live feed of the sun, unfortunately. But if you have proper filtration, you can actually look at our star, the sun, and see something like this. Now, depending on the filter you use, you can actually see some of the surface of the sun bubbling. There's actually convection happening. And you'll actually see material bubbling up from the inner core of the sun up to the surface. Now, you do see some black dots on the surface in this representation, in this planetarium software. Those are called sunspots. Now, they look small, but that's because the sun is gigantic. On average, even the smallest sunspot you see is bigger than the planet Earth. These kinds of like little lanes here, you're talking 5-6 times the Earth, if not larger than that. Let's actually take a look at the sun itself. In reality, like what it looks like right now. So, there is something called SOHO, the Solar and Heliospheric Observatory. That is not it. That is not it either. There it is. That's what I was looking for. Now, SOHO's been in space for many, many, many days. As you can see at the top, it says Mission Day 9245. It's been out there for almost 10,000 days. Many, many years. I remember looking at SOHO years and years and years ago. Now, if you can find this, again, just type in Solar and Heliospheric Observatory, or just type in SOHO Observatory, and you'll find this link. You'll be able to actually click on these pictures to the right. Now, you'll see it says the sun now, and then it has sunspots. You actually have to look at the sun in multiple different spectra to get a good idea of what's going on. So we're going to look at sunspots. So this is actually what the sun looks like right now. And you see there's a scale down here. This length right here, 10 times the size of the Earth. So these are going to be Earth-sized, maybe a little bit bigger. A sunspot is an area of the sun that is magnetically, dense, and it's actually preventing the natural convection. You see kind of like these weird little squiggles. They're really hard to see. It almost looks like it's blurry, but it's not. That's actually convection happening, stuff coming up from the bottom, from the inner core of the sun, bubbling up to the surface, and then cooling off, and then going back down and kind of recycling itself. Well, when you have magnetic field disturbances, these sunspots, as we call them, it doesn't let the material go back down to be reheated, so it sits on the surface and it starts cooling off, and it turns dark to our eyes. You'll also see, you can actually kind of see through the edge of the sun. The sun itself, again, is not solid. It's a ball of hydrogen and plasma, which is a different form, different elemental form. You got liquid, solids, liquids, and gases, and there's actually another form of matter called plasma. And that's what the sun is. Now, what did I mean by looking at the sun in different spectra? Solar and Heliospheric Observatory is in space, and it has multiple multiple sensors on board to look at the sun in different ways. So here's looking at it in more of what we would consider natural light, the yellow color that we're kind of used to. You see the sunspots pretty obviously here. Here it is in that black and white one, the magnetogram. Actually, this is a magnetogram, so you can see positive and negative areas of the sun. The positive areas are probably going to be the brighter ones. The negative areas are going to be the darker ones. You see they're heavily located around sunspots. So there might be a sunspot forming here. You see, again, lots of interesting disturbances along the surface, but, it's just the way it goes with the sun. Now, of course, the sun is rotating, so these spots will travel from left to right, and then disappear from our point of view, and then sometimes new ones will appear, or sometimes they'll flare up, kind of like acne. Oh, that's not what I wanted. They'll flare up like acne on the surface of the sun. Let's look at the sun in, I believe this ultraviolet. You can see lots of activity happening near the sunspot. So in our from our point of view, our eyes only see this dark area. Well, look what's going on here. There's lots of activity, and you actually see these magnetic field lines coming up and over. That's actually really, really cool to see. And you see them on the edges. We call these solar flares when they're hanging off the edge. And it's actually material, the actual surface of the sun, ejecting little particles and energy out into space. And again, you can see it in different colors. Depending on your own eyes, you might see some of these better. I have certain, color deficiencies with my eyes, so the green one looks a little worse than the blue ones for some reason. But there again, you see the sunspots. Again, you can click on any of these and you'll see lots of similarities. This one looks more like what we would call hydrogen alpha, which is the standard image you want to look at the sun in. Hydrogen alpha is the first excited level of hydrogen, and it gives you this very distinct reddish glow. You can see the sunspots and solar flares happening. Now, when solar flares become huge, and I mean huge, we call them a coronal mass. Oh god. Frog, please. That was a frog in my throat. I apologize. Ribbit. We call them coronal mass ejections. This is the same observatory, but now we're looking at the sun with a filter over it. The sun is represented by that circle, and you see these jets of material coming out. You also have this very interesting bright spot down here. I believe this is the planet Venus. We can't see it at night right now, but we do actually get to see it in this. A lot of times with SOHO, you'll see planets and you'll see comets and things like that closer to the sun that we can't see here on the Earth. Due to the fact the sun is really, really bright. So there's, some material flying by. You'll see this little arm. This is actually the arm holding onto the filter, literally just blocking out the sun. And you can see that there's, again, material being blown out, and you can see kind of it curling over here. When you get to huge coronal mass ejections, you'll get these huge loops of material. If a planet gets hit by that, if it doesn't have a good atmosphere and a good magnetic sphere around it, bad things can happen. That's what people assume happened to Mars, or at least Mercury. But when that material gets trapped in our atmosphere, at the North and South Pole, that's what we call the aurora. That's what excites the gases in our atmosphere, and that's what causes the aurora borealis. The northern and southern lights. Where is my thing? There we go. Let's get back to where we were before. Again, as always, if you have questions, please post them in chat. Stop me from just blathering on. Also, if you always see my note, please make sure you have a snack, have a drink. Tell me what you're eating. Tell me what you're drinking. We got some cold water today. We had some little mixed nuts earlier just to get some good quality fats in us and a little bit of carbs to fuel us for this this little endeavor. We are facing south. The sun is always in the southern part of the sky, which means east is to our left, west is to our right. Sun tracks from east to west here on the planet Earth. That is not always the case on other worlds, but for here on the Earth, that is the way it works. We're going to accelerate things. Please don't speed up time. Life is short as it is. And we're going to take a look, and hey, look, before the sun sets, the moon is already out. I actually did have someone argue with me once, not in chat, but in real life, saying that the moon was not visible during the day, and I just was beside myself. Now, you'll notice the sun has set, and the sky is changing color. That is a natural occurrence. You do get light scattered because of our atmosphere. The bright blue during the day, that's very short wavelength light. Think about the rainbow. The rainbow is Roy G. Biv, right? Red, orange, yellow, green, blue, indigo, and violet. The blue, indigo, and violet, those are short wavelength light. They get scattered off, but during sunset like this, you get the longer wavelengths, the reds and the oranges and some of the yellows. They make it through the atmosphere, and so they turn the sky this beautiful color, and you get beautiful sunrises and sunsets. So we started out by talking about the sun. We should probably talk about our other celestial companion, the moon. Tonight, the moon will look something like this. Beautiful thing to see. Always one of the easiest targets. It's not always out, unfortunately, but the moon is one of the easiest targets for any amateur astronomer. All you need is a set of binoculars, or even a small telescope, point it towards the moon. Take a look. Doesn't hurt your eyes. Might be bright. If it's a full moon, it might be actually kind of bright, so you do have to be careful. But, you know, staring at the sun, bad. Staring at the moon, totally okay. The moon, of course, is reflecting back sunlight for us to see. This is the only side of the moon that you can see from the Earth, and that is because the moon is what is called tidally locked. Let's take a look at the moon over here in our other software package. Let's jump over here. And we'll use Universe Sandbox. Take a look at the moon. The moon is our natural satellite orbiting around our planet Earth. As you see here on the Earth, during the daytime you don't really see anything, just the continents. You don't see any city lights or anything like that. During the evening, however, you are able to see civilization as it is. We actually do produce a huge amount of what is called light pollution. I figure we take a look at this before we go to the moon real fast. But yeah, that's light pollution. You can actually see major cities just by looking at them. If you know anything about the geography of the area you're looking at, you can guess which city is where. You know, there's Cairo in Egypt, there's London, there's Spain, Madrid, Spain, there's Paris, France. You can see New York, London, you name it, Chicago, Sao Paulo, Brazil. Just gotta look at the right part of the map. There's Tokyo. Should probably slow this down a little bit. There we go. This is what I use when I make the pre-recorded videos. I usually pick a good spot and just kind of let the Earth rotate because it looks cool. Alright. Let's take a look at our moon, who's right over there. There we go. So there's the moon. A little bit better. You can actually see some relief. I mean, you can actually see the mountains of the moon, some crests here. You can see an indentation over here to the right. Now, the moon is heavily cratered. That is from asteroids and other impacts on the surface of the moon, protecting us here on the Earth. So the moon's actually kind of like a battering ram for us. Kind of helpful. The darker areas are the seas, or the mare of the moon. Long ago, people thought these were oceans of water. I recently saw a nifty picture of the backside of the moon. Yeah, that's actually a picture that's been floating around, and we'll take a look at the backside of the moon here in just a second. If you do have an observatory outside of the lunar orbit, somewhere out here, for example, you can actually look back at the Earth, and you would see the moon and the Earth together. And you would see what's called the backside of the moon, or, you know, people call it the dark side of the moon, and that's not totally true. We'll look at why in just a second. But yeah, you got the lunar highlands, you got the lunar lowlands, you got these lava flows that eventually solidified and turned into nice flat plains, the darker areas. But then you see some craters in those darker areas, which indicates those are actually even younger craters than the area surrounding them. Hey, more viewers. Hello. If you aren't already following, please like and subscribe to the channels. The Dark Side of the Moon is actually a critically acclaimed prog rock album. True, it is. Here we are as we begin to orbit around the moon. You'll see the backside of the moon. That's going to be very similar to that picture that you are referring to. Now, the backside of the moon does get sunlight during what we call a new moon phase. As the moon orbits around the Earth, it reflects a different amount of sunlight back at us. You can see the Earth way back there traveling by. Actually, we're traveling by it. But again, this is the backside of the moon. All the craters are named. Good luck remembering all of them. The backside of the moon, however, you really can only see if you orbit around it, or you have an observatory out past the moon. So why do the phases happen? Well, it has to do with angles and maths. Let's actually leave us here for now. And let's come back to our web browser, you know, good tech. We're going to look at this. I did not make this. I found this. I like using it because it's pretty simple. Little pink dot in the middle. You see a little pink dot shooting up. There's us on the Earth. This is the North Pole of the Earth. We're looking at the Earth from above. Space trig is out of this world. You are not wrong. True. As the moon orbits around the Earth, its angle between our viewpoint and the sun changes. It reflects back sunlight, and so it begins to quote-unquote grow. It's the same size the whole time, but it starts getting brighter and brighter and brighter. 1/4 of its orbit around our planet is considered a first quarter moon. The bright side on the right side is what you call a waxing moon. You hit first quarter, you keep going from a waxing crescent into a waxing gibbous. Gibbous is what we've got going on right now outside. Not full, but not half. When you get to a full moon, the moon has gone exactly 1/2 of its orbit around our planet Earth. The moon is then at opposition, which means it's opposite the sun in the sky. The sun sets and the moon rises at the same time. Right there. Close enough. That's the full moon. Each full moon, at least in the Northern Hemisphere, has a different name. There's the wolf moon, there's a snow moon. I believe this month is the worm moon. Next month is the pink moon. Does the moon actually look pink next month? No. That is just the name of the moon, because in April, at least, lots of certain flowers start to bloom that are pink. Worm moon, that's this month. Well, you wouldn't know it by today, but this is usually when the ground starts to, you know, defrost a little bit. Things start to get warmer. Worms start to come out of the ground, so it's the worm moon. Full moon is on the 28th, so in just a couple of evenings, you'll have a full moon. Then the phases go in reverse, waning gibbous into a third quarter or last quarter moon. It's 3/4 of the way, or it's entering the last quarter of its journey. However you want to look at it. Then you get into a waning crescent. That's what we call our little lounge when we talk about the news. I think that's just for you. I only see one chat popping up from you. Also, Nightbot's behaving itself so far, so that's good. There's the waning crescent. Back to new moon phase, the bright side on the back side of the moon. So it's not exactly the dark side, is it? Now, the moon and the sun are very, very important. Multiple cultures from long, long ago looked at the sun and the moon and believed them to be deities. But they also noticed other objects floating around the sky that weren't always fixed. When you talk about the nighttime sky, the sky has been the same basically for all of human history. There are some variations, you know, things kind of wobble a little bit, but everything moves together. All the stars are what are called fixed stars. However, and of course, because they're fixed stars, you can come up with stories. These are what we call the constellations. We're not going to talk about all of them, but I always like to kind of bring this up and show off what looks like stick figures in the sky. And these are, of course, made of the fixed stars. These constellation groupings do not change. Different deities, different creatures, hybrids, lots of strange things, a lot of imagination goes into this. A lot of these stories, at least the ones that we use in what's called Western astronomy, come from Greek and Roman and Arab. There's also some Egyptian, but all of those also come from older civilizations such as Babylon and Assyria and Sumer. Nonetheless, these objects are considered fixed stars. There were 7 objects that were not fixed. These stars wandered. The sun was considered to be one of these wandering stars. The Greeks called the stars themselves Asteris, and these wandering objects Planetes Asteris. Wandering star. Vagabond. That's where we get the word planet from. The sun and the moon were considered wandering stars. Of course, we know today the sun is a star, the moon is a moon, it's a satellite orbiting around our planet. The other 5 objects are actually other planets of our solar system: Mercury, Venus, Mars, Jupiter, and Saturn. Those are the 7 classical planets: the moon, the sun, and those 5 planets I just mentioned. That's actually super related. Why am I mentioning all this? Look at your calendar. A calendar month is pretty, well, it's not accurate, unfortunately, but it's close to the way the moon's orbit works. A cycle of the moon going from new moon through the phases that we just looked at back to new moon is about 28.5, 29 days, give or take. That's about the length of a month. Of course, some months have 30 days, 31 days, and February only has 28, but that's because people started messing around with the calendar. But the calendar month, the calendar has to do with the cycle of the moon. In fact, the word month comes from the moon. Monday also comes from the moon. All the days of the week are related to these 7 classical planets. So you have Sun, Sunday, Monday is Moon, Tuesday is Mars, and if you speak any Romance language, Martes, that's Tuesday. Wednesday is Mercury, Miércoles. Thursday is Jueves, or Jupiter. Friday is Viernes, Venus. Saturday. Those are the 7 classical planets. Those are 7 days of the week. Technically, all 12 months have 28 days. Yeah, you just gotta kind of scoot some days around. But yeah, it's all built around the moon and how the moon orbits around our planet. Funny how that works, huh? We're gonna look at some constellations. We're gonna look at some planets, and we're gonna look at the motion of the sun through the sky. Now, the sun also travels through 12 distinct constellations. This again comes back to what we're just talking about. Those constellations we call the zodiac constellations. You've got Taurus the Bull, Gemini Twins, Cancer the Crab, Leo the Lion, Virgo, Pisces, Aries the Ram. You've probably heard these. Long ago, astrology and astronomy were considered to be the same. That's not the way it works today. Astrology is more of a, belief system, or, wherever planets are, they happen to somehow interact with you. That's fine and dandy if you want to believe things like that. Astronomy is actually looking at the sky and determining, what's moving and why. It's actually astrophysics, but, they're all the same. Connected. Because we're connected. The reason the sun, the moon, and the planets happen to travel along this little narrow band of constellations is, well, revealed when we come back to this software. The planets happen to be on a flattened out plane. Imagine the equator of the sun traveling out in all directions. All the planets have tried to kind of hit that. No, not all like that. Mercury's a little bit at an angle. Some planets do have a bit of an angle to them, but these are the orbits of the planets of our solar system. You usually break the solar system up into multiple sections. The first section you talk about is the inner solar system. Some people call these the terrestrial planets. We're going to start out by zooming in on the sun and going slightly blind, and we'll zoom back out. Mercury, Venus, Earth, and Mars. These are the first 4 planets of the solar system. And we call them the terrestrial, terra meaning Earth-like planets, or the inner solar system. These planets are rocky worlds. Well, I guess I'd say if it's just us, it seems like an awful waste of space. Yeah, you never know. As we start exploring into cosmology later on in the show, you'll see there's a lot of stuff out there, and maybe nothing else. No one else. That'd be kind of weird. Let's take a look at Mercury. Kind of looks like the moon, doesn't it? It's just a small rocky world orbiting the sun at a very, very high rate of speed. Because Mercury and Venus are closer to the sun than our planet Earth, you don't get to see them at night all that much. You only see them in the early morning, right before the sun rises, or right after the sun is set. You'll see them in the early evening, and then they go to bed within half an hour to an hour after the sun sets. But here's Mercury, small rocky world, very, very hot, no atmosphere. So if you stand right along this line between light and darkness, the Terminator as it's called, half of your body would be scorching, the other half would be freezing because there's no atmosphere to, mix that heat around. And you can see the sun very, very close by from the point of view of Mercury. Venus, the next stop on our trip through the inner solar system, oftentimes is considered to be Earth's evil twin, because it is about the size of our planet Earth. It's about 80%, 85% the size of the Earth. But that's about where things end. Venus rotates the wrong way compared to our planet Earth, and by that I mean the sun rises here on the Earth in the east and sets in the west. On Venus, it would rise in the west and set in the east, which that's kind of weird. There's a very thick carbon dioxide atmosphere, so there's a runaway greenhouse effect. It traps all the heat in from the sun. It's very, very hot. There's only been a couple of landers that have actually landed on the surface of Venus, the Venera landers from the Soviet Union, and they melted really, really fast. There was some chatter about Venus potentially having life last year, I believe. There was some, biomarkers in the upper atmosphere. No one's really kind of followed up on that in the news too much. Could have been a mistake by the sensors. Could have been maybe a small chunk of an asteroid or a meteor. Correction, a comet getting destroyed by the atmosphere. We don't really know. Still investigating it. Venus is a very strange world. Very, very bright because of that atmosphere, and so when it's in the evening sky, you call it the evening star. In the morning sky, it's the morning star. But it, of course, is not a star. It is a planet. You'll notice stars will twinkle. Planets will never twinkle in the sky. Here's the Earth. You'll notice it's rotating pretty fast. We're looking at about 21 hours a second, so it's a day every second. Zoom, zoom, zoom. And the last stop of our trip is actually Mars. Mars is the only planet you can see without a telescope tonight. I'll show you how to find it in just a little bit, but we are going to slow this down a little bit, though. Mars, of course, has been in the news recently because a couple of orbiters and a rover have arrived at the planet. We talk about Mars Perseverance pretty often here. This is the area I always like to teach people about with Mars because, well, it's interesting. Mars is about half the size of the planet Earth, but its day is similar to our own day here on the Earth, 24 hours, 37 minutes long. So it's a little bit longer than a day. We call it a sol. This area is called Tharsis, 3 shield volcanoes, and then Olympus Mons. Olympus Mons is the largest volcano in the entire solar system. It's about 400 miles across. It would take up an entire state. So in New Mexico, Utah, Colorado, Arizona, it's as big as that entire state. And meanwhile, this is about as large as the entire United States. This is Valles Marineris from one side to the other. We're talking crossing from San Francisco all the way to New York, 5 miles or about 8.5 kilometers deep at its deepest point. Mars is a very intriguing world. It kind of makes people imagine things. There were various astronomers looking at Mars, and one whose name is currently eluding me, he actually had an eye problem, and he didn't know it. But he had an eye problem, and he was looking at Mars, and he kept seeing what he was calling canali, on Mars, and so people thought there was water flowing on the surface. Now, there may have been water flowing on the surface in the past, but right now there is no liquid water on the surface of Mars, just lots of craters. I hear a meowing kitty. Hi, Alcyone. We'll talk about you later. Mars does have ice caps made of dry ice, carbon dioxide ice, frozen at the North and South Pole. There's likely liquid water under the surface. We'll see what these rovers start to find, and we'll be talking about Mars Ingenuity, the little helicopter, in just a couple of days, because they're going to be launching it sometime in April. Once you pass Mars, you enter into a belt called the asteroid belt, and you have rocks like this. Now, the bigger asteroids are called actually planetoids. Some of them have been known for a while. They're planetoids. They're dwarf planets. They're sometimes stony, sometimes rocky. They all orbit in very intriguing ways. Some of them spin just like a planet, you know, along an equator. Some of them tumble as if they're rolling instead of, you know, orbiting around and spinning. So it's always kind of an interesting thing to see asteroids in the asteroid belt. They're not all just, you know, potato-shaped. Some of them are round. Now, as we pass the asteroid belt, let's get those rings back. Hold on. Matt Damon had a cooler trip to Mars than Val Kilmer. True. That is true. After you pass the asteroid belt, and represented by this ring here, there's lots of asteroids floating around. You enter into the realm of the giants. Now, these are going to be the larger planets of our solar system, I should say. We're talking about Jupiter, Saturn, Uranus, and Neptune. They are further out, and so you can actually see them at night. Unfortunately, because of the way our orbits work right now, the bigger planets of our solar system, Jupiter and Saturn, they're only visible in the early morning, right before the sunrise. So we can't say, hey, here's how you find them tonight. If we get to them later on in the show, then we'll talk about where they are. Take a look at Jupiter. Come on. Come on. There we go. Now, Jupiter is the largest planet of our solar system. It rotates very, very fast, as you can see, 8 hours and 15 minutes or so. Let's slow that down. Right at the equator. Now, this dark spot right here, this is the Great Red Spot. Through a telescope, you can actually see it if it's a decent-sized telescope. You know, 3 or 4 inches, just a minimal-sized telescope. You'll see the Great Red Spot when it is on the side facing the Earth. There are 4 large moons orbiting around Jupiter. They are called the Galilean moons, the Galilean satellites. I'm not allowed to make commentary about sending more probes to the planet between Saturn and Neptune. Ah, yes. You are speaking of the planet Uranus. We'll get there, and I do know exactly what you're talking about. As a seasoned professional astronomer and planetarian, I can tell you the worst thing you can do is say the planet Uranus in a group made of about 120, 130, like, second graders. That's a terrible idea. It's not like I've done... Okay, I did it once by accident. You gotta say Uranus. I've heard it pronounced both ways. Uranus obviously makes people laugh. Now, Saturn, where are we at? Jupiter. Jupiter has 4 Galilean moons. Io, Europa, Ganymede, and Callisto. The name Galilean comes from Galileo. It's often considered to be the father of modern astronomy. As a legal adult / man-child, it's a hilarious idea. I mean, it is. It is funny. Now, because a lot of these stories come from, like, Greek and Roman, especially constellation stories, I can't really always tell them all, especially in planetarium settings. So you got little kids, and, you know, there's lots of deities taking innocent people for their own whims and things like that, and just never fun. This is a ringless Saturn. I don't know why they didn't put Saturn's rings on here. Lots of death and nudity. True. I don't know why Saturn doesn't have rings around it here, so what we're going to do is jump to a picture of Saturn. Yes, good. The same picture I use every time because it's just pretty. Saturn is known as the ringed giant, but that's kind of a misnomer. All 4 gas giants do have rings, only Saturn's rings are icy and nice and young, and so they reflect a huge amount of sunlight back for us to see. These are not mistakes in the photo. Those are actually moons. There's a moon down here, moon over here, moon right along the edges. It's actually a really cool setup they're called shepherd moons. They actually orbit within the edges of the rings, and their gravitation actually keeps the rings in perfect harmony. The largest of Saturn's moons is actually the one to the bottom left here. That is Titan. Titan is a moon that has an atmosphere. It's the only one that has an atmosphere, and that atmosphere is made of methane. As stuff falls off my desk in the background, I apologize for that. Yes, good. More memes coming in. We're professional here, folks. I swear. Let's go back to the software. And let's actually visit the planet you were just talking about. Let's go visit Uranus. The planet Uranus is... Where are you? There you are. You're down here. Yeah, for some reason the rings disappear from the planets, and they actually also disappear from the orbits. Uranus is the oddball. When you think of planets, when you think of garbage, you think of Hakim. You see a planet picture, you assume north is at the top and south is at the bottom, because that's the way our planet is oriented, so you figure that's the way it is. That's not the way it goes with this planet. Uranus is tilted over on its side, its rings are along its equator, so those are on the side, its moons are orbiting around the planet, also on their side, so the whole entire system... It's like someone took it and just flipped it over. So take a water bottle and just push it over to the side. That's what happened to this planet. No one knows why. That's just the way things are, and oddly enough, we don't send orbiters to visit Uranus and stay there. When we send orbiters out, we send them to Jupiter, and then we kind of slingshot them to Saturn, and then, if we can, we'll send them to either, Uranus or Neptune or Pluto. And that's it. We don't actually send an orbiter to stay at Uranus. We don't send an orbiter to stay at Neptune, and I don't know why. They're interesting worlds. They are very, very far away compared to the Earth, but, we should study them anyway. They don't have as much intrigue because you don't see them at night. You don't really know much about them. You can't just look up and say, oh, look, there's Uranus or there's Neptune. They do require telescopes to see, but, the other planets, as I mentioned before, Mercury, Venus, Mars, Jupiter, Saturn, you don't need a telescope to see them. Neptune is named after the god of the sea, Poseidon in Greek, Neptune in Roman. It's a bright blue planet, the bluish hue, depending again on the atmospheric composition. How much more can we learn about Uranus if we already... Yeah, ha, ha, ha! That's funny. Also, time to make a Star Trek Klingon joke, right? What's interesting about Neptune is that there's actually some cloud structure and interesting features which are not included in this particular simulation. There is a dark spot, just like the red spot on Jupiter, there's a dark spot on Neptune, and it's weirdly... transposes itself. So sometimes it's in the southern hemisphere, and then it'll disappear, and then it'll appear in the northern hemisphere. There's some sort of weird heating going on inside the planet Neptune. Its atmosphere actually shows lots of clouds that it probably shouldn't be, showing. We don't know why. Hi, Elsie. If you hear a kitty, that's Alcyone. We'll talk about her. I'm going to talk about your star in a little bit, honey. We have two critters in our studio on our magical spaceship that we call the USS Tranquility Lane. One is named Alcyone, the other is named Sirius. Both of their stars are out tonight, and I'm going to show you how to find them, as well as finding the planet Mars. As you see, we are back in our planetarium, still facing south, except now facing more southwest. We see the moon again, nice and high in the sky. You never want to use the moon to help find your way around the sky, because the moon is constantly moving. So that's where the moon is tonight. That's where the moon's going to be tomorrow night, the night after that, the night after that, the night after that. So that doesn't really help. The moon has drifted very, very far away. Not helpful for when you're trying to find things in general. On one night, maybe, but not night after night after night. Now, visual astronomy. If you can hold your hand out, if you're able to, hold your arm out and look at your hands, or pick a hand, doesn't matter. Your finger is about a ½ degree. The sky is broken up into what we call degrees, and come on, that's the wrong one. That is also the wrong one. All right, whatever. Lots of ways of breaking the sky up, apparently. We're just going to put them all. Perfect. Anyway, it's 180 degrees from horizon edge to horizon edge. And your finger is about a half degree, depending on the size of your finger. But, you know, for estimation's sake, consider your finger to be a half degree wide. From your index, you know, look at your index finger from the tip of your finger to the middle knuckle. That's about 2 degrees, give or take. The size of your palm is about 5 degrees. Yeah, Nightbot's actually behaving so far. When there's more people, Nightbot seems to get a little more agitated. But, yeah, so 5 degrees, your palm. When you're looking around the sky, I might mention some degrees. That's what I'm talking about. Just use your hand to kind of figure your way around. Now, the easiest constellation to see in the winter and early spring is Orion, the Great Hunter. Now, there's lots of different stories about how Orion got here. Some of them have him being killed by a scorpion. Others have him being accidentally shot by an arrow from a huntress known as Artemis, the moon goddess. He's usually depicted holding on to a club and a lion pelt, or maybe a sword and a shield. In the story with the lion pelt and the club is an unbreakable weapon, and he's on a quest to kill every animal he can, because he wants to kill one of everything, because, you know, he's like the Chad of the nighttime sky. And a scorpion kills him by stinging him in the foot. And that scorpion happens to be the constellation Scorpius, which is in the summer. Orion is in the winter. They're opposite each other, and they're constantly hunting each other down. At least that's the way the story goes. A lot of times, you can actually go back in various cultures and see that this particular part of the sky was super, super important. For example, the Egyptians looked at the constellation that we call Orion, and they apparently considered it to be Osiris, which is the god of the underworld, the god of the dead. His wife was Isis, which is actually represented by Sirius, which is one of the stars we'll find here in just a second. Sirius is the brightest star in Canis Major, the big dog, also the name of my dachshund. Kind of convenient. Orion is also considered to be Gilgamesh if you go far enough back, even back to, you know, ancient Sumerian writing, Sumerian astronomy. This should be Gilgamesh in the sky. So, lots of different stories, lots of different things. You could spend days talking about just certain constellations. But Orion is easy to find. You got 3 stars in the belt. You've got shoulder stars that are fairly bright, knee stars. One of them is really bright. The shoulder star, named Betelgeuse, literally means armpit of the giant. The opposite shoulder of that is Bellatrix. So those of you that are Harry Potter nerds out there, for better or worse, Sirius Black, that's Sirius, the dog star. Bellatrix Lestrange. Bellatrix is actually this star right here. It's the shoulder star of Orion. Betelgeuse Bellatrix Rigel is the knee star of Orion, bright blue. You'll notice difference in color. It's bright blue Rigel, very bright orangey red Betelgeuse. We'll talk about star colors in just a little bit. And then Scythe is this last star over here. The belt stars are named Omnitak, Omnilam, and Mintaka. Their names do not necessarily matter. The point is that they have been named and having been noticed. Senpai noticed them. Many, many different cultures have noticed these stars. If you look at the sky through various cultural lenses, and by that I mean we're using Western astronomy as the lens. Even in Chinese astronomy, they saw and noticed these stars and made a similar shape to what we call Orion. Orion has, you know, the shield out front. Well, this looks a little bit different. This is the Chinese astronomical sky. It looks a little different. All the stories are very different. I don't know any of them, to be completely honest, because I haven't had a chance to study them. Let's come back to Western astronomy. There we go. Let's use Orion to find our way around the sky. Okay? We'll start off with a hard one. Draw a line between Betelgeuse and Scythe. Draw a line this way and keep going. You'll find kind of this weird little square of stars. That is the body of a bunny. That is a constellation called Lepus the Hare. It's right below Orion itself. You do need some imagination, because it does not look like a bunny necessarily to me, but there you go. That's where you find Lepus the Hare. Using Orion's belt stars, we're going to find the brightest star at night. Draw a line through Orion's belt and head to the left. You will find an incredibly bright bluish-colored star, bluish-white colored star named Sirius. Seriously, it's really bright. You can't miss it. It is the brightest star in Canis Major and the brightest star you can see at night. The sun looks brighter to us because we're closer to it, but as we'll see later, stars have intrinsic brightness and then apparent brightness. Intrinsically, Sirius is brighter than the sun, and it's the brightest thing we can see at night. It just looks dimmer because it's further away than the sun is. Now, the other star you want to find during the winter months is Procyon, not because it's all that bright, but because it makes a triangle. To find this triangle, where's my little drawing tool? There we go. We found Sirius. We already know where Betelgeuse is. That's that shoulder star. And then we're going to draw this way to Procyon. So we make a nice upside-down triangle. Procyon is the brightest star in Canis Minor, the little dog, which has only 2 stars in it, so it's basically a dachshund or a hot dog in the sky. Between those 2 constellations is Monoceros, it's a unicorn, but these stars are really, really dim. The winter triangle is visible throughout the winter months, and you'll see as we head into spring, these stars will be getting lower and lower every night to the point where they will disappear from the sky. The distance, because, we're looking at this on a flat screen, your cell phone or on your computer or whatever, the distance from here to here is going to be about 4 times the width of your palm. So you have to understand, hold your arm all the way out, and you're going to see, this is 26 degrees. So yeah, this is about 5 times the size of your palm from Sirius to Betelgeuse, and about 5 times from Procyon to Betelgeuse, and about 5 times from Procyon to Sirius. So again, put your palms up, kind of use that to measure your way around the sky. People might look at you funny, but they can't see you anyway because it's night. Back to Betelgeuse and Rigel and the rest of Orion. Draw a line between Rigel and Betelgeuse and keep going. Oh, I didn't do this right. I gotta tilt the sky a little bit. Let's tilt our head back and look up a little bit more. From Betelgeuse all the way up this way, you're gonna see there's 2 parallel stars. They are about 5 degrees. They're about the width of your palm away from each other. They're also about the same brightness. They look like twins. And actually the stick figures, as you can see, they are 2 brothers, Castor and Pollux. These are the Gemini twins. This is one of those zodiac constellations that I mentioned earlier. The moon was in Gemini just a couple evenings ago. Currently residing in front of Cancer the Crab. Back to Orion, and we're actually going to be losing this in just a few weeks. Draw a line through the belt of Orion and head towards the western horizon. You will find 2 very distinct things. One is a V of stars. That V of stars is the face of Taurus the Bull. Right in here. That V of stars has a bright red star named Aldebaran, the Eye of the Bull, the Watcher. Behind that is another open star cluster named the Pleiades, the 7 sisters, Subaru. This is Alcyone. That's why the cat has her name. This grouping of stars is an open star cluster. These were stars that were all formed about the same time, from about the same material, and they're kind of floating apart from each other. There's different types of star clusters. There's what's called open star clusters, which look like this. You see them pretty prevalently during the winter months. During the summer months, we see a different kind of star cluster called a globular cluster. Those orbit much closer to the core of our Milky Way galaxy. The Milky Way, by the way, is this cloud you see kind of in the background. If I get rid of the atmosphere, it makes it a little bit better. There you go. You see this cloud in the background. You saw it in the other software. That is our galaxy, the Milky Way. We'll talk about what that means in just a second. One last constellation and one last star to find. Go back to Orion. This time we're going to use Rigel. Well, we can use Scythe and draw a line up through between Betelgeuse and Bellatrix. You will find a nice bright star named Capella. It actually kind of completes a 6 bright star trek. You go from Rigel to Sirius to Procyon, up to Castor and Pollux, and then back over to Capella, and then come back down to Aldebaran. So 1, 2, 3, 4, 5, 6. Okay, so 7 stars. My apologies. Capella is part of Auriga, the charioteer. It looks kind of like home plate, but with an extra little side to it. So a 6-sided object instead of a 5-sided home plate. For my baseball friends and family out there. Baseball is starting up soon. Now, we found 6 constellations so far, just using Orion. Let's find a planet. As I said, there's only one planet visible at night tonight without a telescope, and that is the planet Mars. We've already kind of found it, and if you've been keeping track over the last few weeks of our other shows, you know it's within the constellation Taurus the Bull. So we just drew this line from the belt stars through Aldebaran and through to the Pleiades. Well, right above the V of stars, you're going to find a bright red dot. That red dot will not be twinkling. That is where the planet Mars is tonight. And it looks like if you go out around 9 o'clock, you'll actually be able to see Tharsis through a telescope. So that's pretty cool. Mars just a few weeks ago was right below the Pleiades, and it's slowly been drifting this way from east to west. There we go. Other constellations of note. Actually, if you can see the moon, which you should be able to, you'll be able to see Leo the Lion. That's the other constellation I like talking about. Cancer is really hard to see. The stars are really dim. Leo the Lion actually looks like a backwards question mark, and the moon is right in front of Leo tonight. So this won't be helpful tomorrow or the night afterwards. But this backwards question mark shape makes up the head. The triangle makes a tail. There's a bright blue star named Regulus at the base of the question mark. Very much like a sphinx. Is it not? Yeah. Let's talk about stars. I've been talking about some star groupings, obviously. Let's talk about the stars themselves. Our sun is the star, I should say, that we orbit around. It's considered to be a yellow dwarf star. There's a grouping, there's a thing that we call the main sequence. I guess I should just describe it. I should probably just show you. To graph what stars are like, to try to understand what stars are like, scientists created what we call the main sequence of stars. Is actually the Hertzsprung-Russell diagram, and it's not on screen, is it? There we go. There's the HR diagram. Stars are classified like this. Main sequence stars, which is stars just living their lives, doing their thing. There are stars that are called giant stars, like Aldebaran, which we've mentioned. There's also a group of stars called supergiants, which are actually even bigger. You see those in the top right here. And you also see what are called white dwarfs. These are stars that have already died and are no longer actual stars. Stars along the main sequence are fusing hydrogen into helium, or helium into lithium, or some element into something else, living their lives. Stars that are in giant phase, so up here, the scale, I guess I should talk about. So on the left side, this is luminosity. The higher up you go, the brighter the star intrinsically is. The lower you go, the dimmer it is. The bottom is temperature. The more to the left, the more blue, the hotter the star is. The more towards the right, the more red, the colder the star is. Now, cold is relative. We're still talking, 3,000 degrees Celsius, give or take. So hot for a human, cold for a star. The sun we put right in the middle, because that's what we can study. We study the sun. That's what we use as our measuring stick. All the stars that are up here are physically bigger, physically brighter, but not necessarily hotter. If they're blue and giant, then they're hotter, but if they're red, they are colder than the sun. Conversely, after a star has died, you get a remnant left behind called a white dwarf, and those are very, very small. They're just kind of the hot core. Imagine, you have a barbecue, and when you're done, you have little embers still glowing, right? That's what's going on with a white dwarf. It's a glowing ember of a star. That's kind of an analogy. It's not exactly how, but it's an idea. Neutron stars would be way down here. They're much, much smaller. They're even more compact than a white dwarf. That's what happens when a really huge star explodes and leaves behind a cloud. of gas and dust that we call a nebula. Now, there's different types of nebulae. There are round-shaped nebulae that are called planetary nebula, and then there's supernova remnants. Let's take a look. I don't think we have... Come on. Where's my little finder thing? Finder. Thank you. I'm a professional. Tonight we could see this. There we go. This is the remnant of a star that has exploded violently. This is a supernova remnant with a neutron star deep inside of it. This is the Crab Nebula. Crab people. This is a star that has exploded violently. Why? Well, we'll talk about that in just a little bit. But stars that are giants can either die quietly or they will explode violently. It depends on how massive they were. If they were sun-sized, mass-wise, or maybe slightly bigger, they'll die quietly. They'll make a ring nebula, ring-style nebula. If they are much more massive than the sun, they will explode violently. Let's see, is the ring nebula out? Oh, it is. Perfect. That is not the one that I wanted. Also perfect. Thank you. Let me see if I can get you a picture of the other one so I can actually show you rather than just explaining it. I need to let the sun... There we go. This is what happens when a star like the sun dies. The outer layer, the star will puff up, become a red giant, and then the outer layers just kind of float away. Hydrogen is the bright red layer, then you're going to have helium, and then, oxygen, nitrogen, lithium, all that kind of stuff. Left behind in the middle, though, that's the white dwarf. This is very different than the other one, isn't it? This is a nice, quiet kind of, it just looks like a big eyeball. If you look at it through a telescope, it looks like a ghostly eyeball in the sky. But the other one that we looked at just a second ago, that was much more violent, right? You could tell there was a lot of violence in that explosion. When stars die, they leave behind clouds of gas and dust. Here we are looking at Orion. You can see the 3 belt stars of Orion right up here. Just below Orion's belt is what is called the Orion Nebula. This right here is actually an area where stars are being born. Now, they're not born like a human would be born. There's no gestation period. We're talking about cloud material and dust coalescing and eventually spontaneously fusing hydrogen into helium and releasing energy, and that starts a heating process and a nuclear chain reaction to make stars, quote-unquote, be born onto the main sequence. Let's look at stars and compare them, shall we? Let's go back to this software. I love using this. I know Markiplier was using this to explode things, but I like using this for education. Let's get rid of that. So let's look at the sun. We're going to pause motion real fast, and we're going to put the sun. This is our star, the sun. Hello, sun. Are you winning, sun? Let's take a look at some stars. As we saw on the list there, red stars tend to be dimmer, and in this case, much smaller. This is a red dwarf star called Wolf 359. If you are a Star Trek fan, you know all about Wolf 359. The Battle of Wolf 359. But as you can see, it is much dimmer than the sun, and physically much smaller than the sun. But let's take a look at other stars. I do need to make some room, though. I need to kind of move away. Let's look at Sirius. Hey, buddy. Oh, that's a red star, as you can see. There's a yellow star, as you can see. It's a very distinct yellowish color. Now let's look at Sirius. Sirius is like a bluish white. Sirius is very, very bright. You can see it is slightly bigger than the sun. Very, very cool. These are not their actual positions. We're just kind of putting them on a grid to compare them. We talked about Rigel, the knee of Orion. Well, look at that. Rigel is a giant blue star. This is Sirius. That's Rigel in the background. Compared to Wolf 359 and Our own sun. That star is huge! And it's not even the biggest one. Let's keep going, shall we? We talked about Betelgeuse, or Betelgeuse, the armpit of Orion, the shoulder of Orion. Remember when I showed you that little HR diagram and said there are giants, red giants, and then supergiants? This is a supergiant star. Look at our sun. Hold on, where's the sun? There's the sun right there. And you can see that star is gigantic, Gigantor. Look at how small little Wolf 359 is, and little Sirius. Even Rigel, which is gigantic, is still really, really small compared to Betelgeuse. And Teres, the heart of Scorpio, is also one of these giant stars. What is going on here? Let's put it there. You can see, excuse me, it's about the same size as Betelgeuse, physically. Arcturus. Arcturus is a star you could probably see tonight if you're out late enough. It's a little bit bigger than the sun, but it's also a bright yellowish colored star. So there are stars like our sun. There are stars bigger than the sun. There are stars smaller than the sun. Really cool, right? Let's clear this real fast. We're going to do something artificial. We're going to explode a star real fast. Well, actually, let's go back to our solar system really fast. Just to give you an example, just to make you understand the immense enormity of these stars. Look at the sun compared to our solar system. It's just a little dot in the middle. Our Earth is 93 million miles, or 150,000 kilometers away from the sun. Let's bring one of those objects here, shall we? Where's Betelgeuse? There's Betelgeuse. Betelgeuse, as a star, all on its own, takes up all the space between where our sun is now, almost out to the orbit of the planet Jupiter. So all the inner planets and the asteroid belt are gone. Just because of this one star. Now, eventually what will happen with Betelgeuse is it will explode. And it will consume anything around it. So if there's a solar system around Betelgeuse, which there likely isn't anymore, it'll all go bye-bye. And a cloud will be left behind. So again, as you saw before, there's actually different ways of this happening. There's supernovas. There's different types of supernovas. Type 1A, type 2. There's also novas, which is just a white dwarf star exploding. Material exploding off of its surface. From explosions like this, we see the stars seeding material. And what do I mean by that? Well, stars are fusion reactors. Stars fuse hydrogen into helium, helium into lithium and carbon and oxygen, nitrogen. Eventually, they fuse everything up to iron. Or iron, if you're a Pittsburgher. And, once you get to iron, the star starts to run out of energy, starts taking more energy to keep fusion going than it produces, so the star starts to cool off, starts to turn red, starts to puff up to try to keep that equilibrium, to keep the pressure high, and then eventually it either just fluffs out of its outer layers, or it implodes violently and explodes like this. Implosion, then an explosion. But what you see here is actually going to be hydrogen and all these other elements of the periodic table floating out into space. There's going to be dust floating around too, actual solid material floating around. Some of that will then recoalesce and make new planets and new stars. And on some of those planets you might find little rocky worlds like our own, maybe creatures like us. So, as I said multiple times before, I like to call people stardusters, because you and I and everybody you know and everybody I know, we're all made of the dust of stars. We are stardust. Carl Sagan said we are star stuff. Yeah, we're stardust. Now, this happens all over the place in what we call the Milky Way. I've kind of mentioned it offhand. You can kind of see it in the background. It's that bright blue over here, and then it's more yellowish orange in the middle here. The younger, hotter, bluer stars tend to get formed in the outer portions of this galaxy, our galaxy, and most spiral galaxies. And you have older stars more towards the middle. Now, I want you to understand the structure of everything. So we live in a home, an apartment, or a house, or whatever, in a city, on a street. So you think of your address, your place in space, your home address, your city, your street address. David Bowie said ground control to Major Tom, yeah. Your circuit's dead. There's something wrong. Can you hear me, Major Tom? Can you hear me, Major Tom? Yes, good. So, we go from city to state or county, country, you know, northern hemisphere, southern hemisphere, however you want to do it, but ultimately your address ends with planet Earth, but it doesn't really end there. It then goes to solar system. So you are on planet number 3 of the Sol or Sun system, right? Well, our star, the Sun, as you see, as we keep zooming away, it's, I mean, we've got the little label on it, but from this distance, do you even see the Sun? We know it's there because it's labeled, like a little circle around it, but you don't really see it anymore because it's not very bright. Our star, the Sun, is but one of millions of stars that orbit in a pattern like this. This is what we call the Milky Way. Now, from above, it would probably look something like this. There's actually different kinds of spirals. Some of them are spirals like this, whirlpools. Others are called barred spirals, and they have a little bar down the middle of them, caused by gravitational waves and dark matter. There's clouds of gas and dust and stars and planets and dark matter, which we can't even see, but we can kind of detect. We don't really know what's going on with it. And that usually tends to occupy the spiraling arms. Now, that's not what our galaxy looks like to us, does it? Why? Well, we happen to be in the spiral arms, so our point of view looks more like this. So at night, when you look up, you're actually looking at the spiral arms of the Milky Way during the winter, and during the summer, you're actually looking towards the heart of the galaxy. Our Milky Way is not alone. It's actually part of something called the local group of galaxies. There's a grouping of nearby galaxies, come on, that are all kind of gravitationally bound together. Our Milky Way will look a little bit different now. That's a little lower quality. It upsets me a little bit, but there's the Milky Way. And you see there's like the Sagittarius dwarf galaxy and all these other little galaxies that are kind of in orbit around our Milky Way galaxy. If you live in the southern hemisphere, if you live in Australia or South Africa or just anywhere south of the equator, at night you can actually see what are called the Magellanic Clouds, named for Magellan, even though the native peoples there already knew about them. They're named after Magellan, who was a European explorer. Sure. These are chunks of what was likely another galaxy or two that got torn apart by the Milky Way. And I mean, we're in 3D space, so I'm trying to orient myself here. Now, these distances are huge. When we were talking about the solar system, we were talking about, you know, light taking anywhere from a couple of minutes to a few hours to cross the solar system. At the speed of light to travel between the galaxies, you're talking about thousands to millions of years, depending on the distance, and it only gets larger from there. The nearest large galaxy is called the Andromeda Galaxy. It's this one right up here. It's very similar to the Milky Way. It is about 2.25 million light years away, so at the speed of light, it takes 2.25 million years to get there. But this spiral galaxy is on a collision course with our own Milky Way. And there's kind of a good look at the local group. What's not in here is what's called the Virgo cluster, which is the next phase of the address. You go Earth to Sol system to Milky Way to local group to Virgo cluster and then Virgo supercluster. To complete that, and then the Virgo supercluster is part of the known universe. That is the wrong simulation. There we go. This is Andromeda on top, and the Milky Way being a submissive bottom. Yikes! The two are going to collide, and they're going to merge. Now, in some cases, you will see stars will get tossed out into space. In other cases, you'll see stars begin to orbit each other and, kind of merge into one new galaxy. There's a very rare statistical probability of some of these stars actually colliding because the distance between stars is pretty big. But you never know. Sometimes... excuse me. Sometimes they could collide. But there we go. That is the eventual fate of our Milky Way in millions of years from now, so don't worry about it too much. This is actually something that happens in space, is galaxies collide with each other. They use their gravity and they cannibalize each other to make new galaxies. It's very, very cute. Come back to where we were before. Now, Andromeda is visible very briefly tonight, and we're not really going to be able to see it. It's going to be too low to the horizon, so I'm not really going to mention it. But there is another spiral galaxy you can see tonight, and we're actually going to look north, kind of end our show by doing the last little bit, finding our way north. Now, we've been looking south the whole time. That's where all the cool stuff is right now. And knowing how to find north is always helpful, because, of course, if you know where north is, you know where south, east, and west are in relation. And, of course, if you're navigating or if you're out camping or something, it's always good to be able to kind of track where you're going. Now, the easiest thing to find... I'm actually going to reset time, because, that's really bright. I apologize. I'm going to reset time a little bit, because I want to look right at sunset, because I want to show you the motion of these things. The Big Dipper is possibly one of the most easily recognized things in the sky. It is not a constellation, it is an asterism. This is really weird. So the Big Dipper is a portion of Ursa Major, the Big Bear, in the sky. The Little Dipper is the entire constellation Ursa Minor. Don't ask me why one is a constellation, one is not. The Big Dipper is an asterism. The Big Dipper has 3 stars in its tail and 4 stars in its cup. So 1, 2, 3 stars. 1, 2, 3, 4 stars. These last 2 are about the width of your hand in the sky. They are called the pointer stars. They point you to Polaris. The open side of the Dipper goes this way. And there's Polaris, the pole star, the north star, the lodestar. It's the tail star of Ursa Minor, the Little Bear. There's a story about this Big Dipper shape. As the Big Dipper is right at sunset, just above the horizon, kind of open this way, it's pouring out a little bit of water, isn't it? Night after night, the Big Dipper will get higher and higher in the sky, and that signifies the wet seasons are here. The Dipper is hypothetically pouring out water. Now, during the summer months, at soon as sunset, the Big Dipper is already high in the sky, and it's going to start getting lower and lower. But you can see, if you follow the Dipper, it gets higher up in the sky. This is when it would be pouring out water. During the winter months, the Big Dipper is nice and low in the sky. And so that would be the dry months. Those would be when the months when the water is not falling and the water is being collected by the Dipper. But as you can see, the North Star, Polaris, does not really move. It just kind of sits in the same portion of the sky. And get rid of the atmosphere, even though the sun is coming up. You can still see Polaris is still sitting right there. Polaris has not always been the North Star. There's a star named Thuban. It's actually this one right here. The Earth used to point towards that star, and that was its North Star for a good long while and over a period of years. The Earth, which wobbles kind of like a top, over a period of years, the Earth began to point more towards Polaris. Polaris does make a small little circle in the sky, but for all intents and purposes, it basically stays stationary in that portion of the sky. Deep breaths. Take some deep breaths, relax, enjoy this. I try to use astronomy as a conveyance for information, for inspiring people to do art and music and science, but it's also a time to kind of sit down and reflect on yourself. As someone mentioned in chat earlier, you know, there's all this space out there. We're talking about all these things in the universe, but are we alone? I don't know. I want you to sit and just kind of reflect. How are you connected to the universe? You've got stardust in your blood. That's for sure. Sit back and relax. Go outside, look at the moon. Stay up a little later sometimes just to kind of take in the nighttime sky. If you can. Work dependent, of course. The sky doesn't change too much on a weekly basis, so the sky will look just about the same for the next few days, few weeks. But eventually, what we call Orion and all of this that we talked about in our show will set, and some new constellations will rise, starting with Leo and Virgo, and then we'll get Scorpio and Sagittarius, and we're also going to have what's called the Summer Triangle rising up into the sky, and those are stars you only see during the summer months. So we'll talk about them when we get to that point. And so these fixed stars, these cycles, they remain the same, but the motion of the planets always change. So there's always something to talk about, always something new. More importantly is always chatting. I appreciate you in chat, and I appreciate those of you that on other sections on YouTube and over on Facebook that we're also chatting. I do appreciate that. Also appreciate the many of you that just followed. The General Gelatinous was our last follow. We do appreciate that. Our goal is to just sit here and enjoy the universe itself from the comfort of our studio and educate you. I know a lot of people aren't able to go to planetariums and things right now, so... And even if you could, there's still a possibility of you maybe being in the hospital or maybe... You know, nursing homes, things like that. People just aren't able to travel the way they could or should. And so that's kind of what we're here for, is just to kind of give some inspiration, give some education, and hopefully inspire you, maybe uplift you a little bit. And the more people like to chat, the better. Or if you live in an area without a planetarium, that is also a possibility. If you do live in an area without a planetarium, maybe you can learn what we're doing here and actually make your own. This software does have, this Stellarium software that I'm using here, does have a setting to do a fisheye lens projection for planetariums, so you could hypothetically make your own open source planetarium software with it, or planetarium with it by buying a projector with a fisheye lens and using this as your software. Could be pretty cool. But yeah, that's the totality of our show. Questions are always good. Comments are also always good. If not, we can always call it a day. I never tire of your comments, friend. Yesterday was Monday was rapid fire comments because we had 20-something people here, all commenting at the same time. So it was kind of like me trying to keep an eye on the screen and keep an eye on chat, and I don't have chat visible for everybody, so I just kind of had to wing it. I wish I could be here more consistently. Yeah, no, you know what? It's okay. Not everybody can make it every day, and it's totally understood. And You know, but again, because the sky doesn't really change on a weekly basis, I don't expect people to show up every time, because you're going to hear a lot of the same things. In some cases, that's good, because it's repetition. In other cases, you might find it boring, because you're hearing the same thing. That's why I'm trying to make more offline content, more videos you can kind of click on and learn at your own pace. Remember long ago I said I was going to do Astronomy 101 stuff, and then it just never happened. You know, I just mentally never got my brain to settle down to do it. Well, I did finally do an Astronomy 101, and episode 0, kind of just like a primer of here's what we're going to do. I never got to hear about your thing with PBS. Oh, so that went nowhere. The city of Albuquerque did not opt to pick me up because apparently I don't have any sort of content that they want. And that's okay. What it did was it ticked me off, and it told me I need to get good. As the gamers say, get good scrub. So what it told me was I needed to get good with my production, and I needed to get good with what I'm doing. So I'm going to kind of start working more on making astronomy stuff for, you know, upload to YouTube. And out of I guess vindictive spite, you know, by this time next year I'm hoping to have a good 20 or 30 episodes of Astronomy 101 up, and then they'll be like, oh, I'd love to have your content. Yeah, it's too late now, buddy. Sorry. The only thing that really concerned me with that entire setup was if they were to pick up my content, they would own my content. So whatever they broadcasted would become theirs. Obviously the live stuff, you know, if we're just, you know, doing live chats with locals, whatever. But like the pre-recorded stuff that I upload, if they were to pick that up, they would own it. And that's concerning to me. So, you know, that's just one of those things. It happens. I was really hopeful because, you know, there would have been some sort of small stipend monthly, which would help, you know, buy more hard drives and things like that, because as I'm making more videos, I'm quickly realizing that I am inhaling hard drive space. I'm glad I have a 4 terabyte. But that one's only got a terabyte left already. Yeah. So I'm gonna need to eventually create probably a network access drive, you know, an NAS. And probably use a Raspberry Pi, or maybe just make a Linux box and do it that way. Makes you miss Price Watch. Yeah, well, you know, in my head, I already know what I'm going to do. I'm going to probably, again, get like 3 or 4 hard drives and either make a Linux box or, you know, make a Raspberry Pi box and make a little network storage thing and just dump everything onto there. So my PC will have it set up, and whenever I finish recording, it'll stay on the PC till I'm fully done editing it and all that, and then I'll dump it onto the network drive and store it there. And then my wife can store all of her stuff on it too. But like right now, I'm looking at this PC that I stream from. It needs a new solid-state drive for the Windows drive. That one's only a 500 gig, and it's actually almost full because reasons. And so I need to get a terabyte for that. Just picked up a MacBook, a little bit older MacBook, but it has a really slow drive, so it needs an update. MacBook Pro. So yeah, some technology stuff. Those Biden bucks are going to go to you know, paying some health stuff and maybe buying a hard drive or two to kind of upgrade what we got. And then hopefully this will if you're cool with 3.5 inch, yeah, so like that's what's going to go into the NAS. I'm going to build I'll use the traditional 3.5 inch drives, because you know, the platter drives are fine. Yeah, the laptop, the 1 terabyte one's about $100, which isn't terrible. The solid state one that I'm putting into both the MacBook and to this thing, they're both $100. Actually, were a little bit cheaper up until the whole coronavirus thing, and then, you know, prices are slowly climbing for hard drives. Good luck finding a video card right now. The RTX, the NVIDIA market is completely toast, and the AMD Radeon market is now becoming toast because of the Radeon market kind of filling in for everybody. Yeah, I've actually got an NVMe drive sitting right here in front of me as well, because I'm going to upgrade the MacBook Air that we have as well. We've got technology everywhere. The only thing I don't actually have online right now is a Linux box, and that's only because I haven't gotten around to it. I have an old case here, my previous case, that I'm going to renovate, so to speak, and then put Linux on it, probably Ubuntu, and run that as a just a Linux computer just to have on. Might even just use that as the server for everything. I don't know. I just need to see how much space I have for everything, because, you know, I gotta leave room for the dog below. There is some space behind one of my monitors that a small NAS would fit, but that case is huge, so that would not work. So I gotta decide what I want to do. I've really become kind of infatuated with learning how to use Linux. I'm not sure why I have a frog in my throat today. It's really annoying. I apologize for clearing my throat in your ear. Yeah, see, like that 12 terabytes for 200 bucks, like that's dirt cheap. I can dig that. $200 for 12 terabytes, that's just incredibly dumb. Like that's an incredible price. Of course, I need to get that money first. Gotta get that bread. So hopefully some more work will come my way, or I can pick up at least a temp job, part-time job while I do this, because this is really what I want to do. I want to focus on this. It does take up a huge amount of time, honestly. These little streams, you know, hour and a half, 2 hours, that's not a big deal. I don't mind sitting here talking. It's fun. But the video editing and all that, and the scripting, that's taking me a lot more. It's taken a lot more adjustment in my brain and how to schedule my days out and things like that. Solid state drive for workspace, platters for the storage vault. Yep, that's literally what I got going on here. I've got a solid state for the Windows drive. I've got a separate solid state for the applications. So when I have to install something, if it lets me install it somewhere else, then I put it on that secondary drive, my D drive. Unless it's something Windows proprietary, which forces it on a C drive, which kind of sucks, but whatever. And then I've got my E drive, which is my 4 terabyte solid state hybrid drive. And that's where I store all my documents and all that kind of stuff, and video editing all goes there. And then I've got a couple of spare drives. I've got one that literally is just music, and I mean, that's music I've ripped off of my own CDs. It's music I've produced and made. That all goes on that particular drive. That's the music drive. And then there's one last drive that's just like a spare remnant drive left over from my last computer that's just kind of there for, you know, dumping when I have to fix other people's computers. I'll just dump stuff onto that drive to, you know, store stuff there. Let's not consider the additional costs if you move into going on air, camera, lighting. So, I actually have a HD, it's not a 4K, but I do have an HD 1080p webcam, and we have our Canon 80D, which takes 4K video. So we have some camera stuff already, and we have a lighting kit for photography that we can, you know, and a background kit that we can use, that we have for photography that we can use for stuff like that. And I have a ring light, LED ring light that, you know, people use for like doing video, makeup tutorials and stuff like that. I already have that stuff. I already have everything I need. I just need an audience. I need more gumption to kind of keep making stuff. It just gets really hard when there are times where I'll be editing and it's like 4 or 5 in the morning, and I'm like, I should have been in bed 2 hours ago. And Captain Ahab has to get his whale. I got to finish this edit. I want to get it done. And then I either never uploaded it, or I just, you know, it just feels bad. I'm learning on the fly, and it's like embarrassing, I guess. I need to stop being a perfectionist. That's my biggest thing, is I want the highest quality possible, because I've seen some really bad videos, and you know, videos where people are coughing all the time on pre-recorded stuff. Live, you know, you gotta expect things like that, but like people on pre-recorded videos coughing, or, you know, making noise and like bumping their mics and stuff, and I can't stand it. And so I spend extra time editing out extra sounds and things like that, and getting rid of breaths, and it's all subtle. Most people probably don't notice or even care because you're too busy watching the video, but to me it matters, because if my name's attached to it, I want it to be well produced. The problem with doing something well produced, especially when it's just 2 people, is that it takes up a lot of your time. Like, I've got 5 script. You control your own production standards. Yeah. No, the only thing I don't really have is I don't have a really good intro and exit. I don't think that video, it looks kind of funky because I made it in 1080p when I should have made it in 4K. And so when I'm done, I got a couple of jobs I'm working on, some computers I'm repairing. When I'm done with those, I think I'm going to redo the logo a little bit. Keep the little moon maiden and all that stuff for other things, but I'm going to make something that looks more like a NASA patch. I think that would be kind of cool to have something. Let's see here. If I could spell, it'd be helpful. You know, I really had one of those moments where, like, I sat down and was like, I think it'd be cooler to have, like, a mission patch looking thing. Not the circular mission patches. Make a credits montage like the intro. Yeah, I mean, that's actually something I've been considering. Or like an anime style intro with like ridiculous music, and, you know, there's always like the anime protagonist like holding his hand up to the sky. In fact, here, let's get rid of this. There we go. So, like, I was thinking mission patches, you know, like this triangular thing up here, this shuttle thing, something like this, maybe upside down, maybe rounded. I'm looking, you know, there's a mission patch for SpaceX. Introduce celestial bodies like characters. Well, yeah, that's what I mean, like anime style. Like here's Earth-chan, and here's Mars-kun, and yeah, that is on the list of, that is on my list of things to do. Thinking some sort of patch, maybe something like this, maybe something triangular, something kind of Star Trek-y, kind of Space Force-ish, but with Earthshine and, you know, the moon, things like that. I mean, that one's just kind of silly, but it's also kind of cool. That's simple. It's just a couple circles and whatever. But, you know, thinking of making a new logo, and then, you know, that intro thing is again on the list, and I've been trying to figure out how to do that, like, you know, how I want to do that. Personally, I've always liked the Apollo mission patches and the Red Worm NASA. Yeah. I mean, there's collecting patches is something that a buddy of mine does, but he collects like military patches. If I had the disposable income, I would be buying NASA and like space patches all the time. But like, this is really cool. I think it'd just be kind of cool to have more of a definite space theme to it, as if you're on boarding our ship. Because, again, the whole premise behind this is that our studio is just a section of, you know, think of Star Trek, think of a spaceship, right? On the Enterprise, there was a stellar cartography area. That's where you go to like look at where you're at in space and all that. So that's kind of what our planetarium is. And then you had 10 forward. That was the lounge, and that's kind of what our Friday thing's supposed to be, the lounge where you hang out and talk. And so we call that the Waiting Crescent. So like in my mind, I have this all kind of written out, and I have to figure out how to explain it better. Eventually, I need to make a website, or at least a blog, so that I can upload stuff there and, you know, type out interesting things, or on the Von Braun. Yeah. Lots of social places, lots of things. It's just one of those things that I have an idea and I know what I want to do. There's so much to do, and I don't want to overwhelm myself, because inevitably when I start thinking about all the excessive numbers of things I need to do, I shut down mentally, because I'm just like, I'm never going to get this done. And mentally, it's better to, you know, focus on small little things to get done. So, you know, my goal for the next couple weeks is to work on a patch, get a patch made, and use that as a logo. And then, you know, start rebuilding the intro and do more fun things, like, again, kind of like what you said, you know, have like a Pluto standing in the, you know, Pluto Chan in the background, kind of sad and angry because she's no longer a planet, or he's no longer a planet, however you want to do it. Ideally, we're going to make it an anime style intro, and all the planets are going to be, you know, anime girls. They're going to be magical girls, but they're going to be anime stylized, and I already know who I'd love to do that artwork for me, but I have to pay her, which means I need to get some money first. And yeah, I have some ideas. Side note, because again, I am an anime nerd, if you've never seen or heard of it, which is fine if you haven't, there is a anime called Planetes. Yeah, it's this one. It's great. Has a great intro, talks about basically human space flight, or human flight in general from the beginning. Starts out, you know, by showing, you know, the Wright brothers and stuff like that, and then showing early rocketry and the V2 and stuff like that. And it might be out of print now. It's from about a decade and a half ago. It's from, yeah, 99 to 2004 for the manga. And the series was 2003, 2004. But I do have it. Tokyo Pop and Bandai were the ones that brought it here to the States, and I actually have it, and it's one of my favorite things to watch. The Japanese Space Agency, the JAXA, they actually were involved in it, so they helped make sure that when they had scenes in space, you know, things move the way they would, you know, in low gravity or zero gravity, things like that. No sounds outside of the spaceship. And the story focuses around what are in essence trash collectors in space, and everybody in space looks down on them, just like people look down on janitors here. They're in space and still get looked down on, because, you know, you got all these other people that are traveling to other planets and you know, to the moon, doing all that kind of stuff, and yet you got these schmucks in low Earth orbit cleaning up everybody else's junk and debris, which is a vital thing, because there's lots of space junk up there right now. And, you know, eventually we're going to need to do that. There's actually a couple of companies, one of which is, oh goodness, what are they called? Astroscale. Val Kilmer was a space gen. Val Kilmer used to be a resident. Actually, he might still be a resident of New Mexico, believe it or not. He lives up in or near Santa Fe. I actually saw him once at a restaurant. You see lots of famous people, especially in Santa Fe. If you like, what you call it, Game of Thrones, except season 8, yes, I know, but if you like Game of Thrones, George R.R. Martin, he lives like an hour north of where I live, so. Anyway, so what's interesting about, seriously, even Futurama address, yeah, so space junk. Space junk is a thing, and this little, like, orbital map is terrifying when you look at it. Dead and dying satellites all over the place. Yay! There's even now a mirror floating around because they did a spacewalk the other day, and a mirror came off. Another mirror came off of somebody, and now it's just kind of floating around in space. I mean, it looks cool, but this ain't healthy for space travel. Like, the Earth is that orb in the middle there, and all of this is just literally junk. Some of it is still functional, some of it is dead. Then what? What do you do when you can't even leave your own planet? You saw it in the movie WALL-E, right? You see all the junk on the Earth, and you got all that stuff up there. All it would need is mild deceleration. Yep, so that's what Astroscale... Again, I'm not related to them in any way, shape, or form, but Astroscale... I applied to work for them, and they told me to go fly a kite. They have microsatellites that they are going to be launching up into space. You can kind of see one down here. End-of-life services and active space debris removal. These things are these little microsatellites that they want to send up to attach themselves to dead or dying satellites and then deorbit them, exactly what you're talking about. And so they, I believe, just got the Astroscale Space Sweepers. Yeah, that's a great thing. They are literally doing what we're talking about. They're one of the few startups that have been popping up, and their idea is sending up microsatellites to attach themselves to certain satellites, not collide with them, but actually attach themselves, and then slowly begin to use thrusters to decelerate them and bring them into an orbit where they can actually fall into the Earth and burn up in the atmosphere. So the satellites themselves are not reusable. These are literally going up, burning up, and that's it. I forget the actual program name, but part of the original design requirements for the space shuttle was intended to be a launch and physically steal Soviet satellites to return to the... Well, yeah, I mean... There's lots of shenanigans with the shuttle, and oh god, what was the Soviet one called? I can't remember it right now. Why? Damn, what happened? My brain is dying. Not Baikonur. Baikonur is the... Nope, no, that's wrong. Baikonur is where they were launched from. Baikonur Cosmodrome. The Buran. That's what it was called. The Buran. The Buran looked exactly like ours, and it was all, like, automated back in the 80s, which is cool. Sadly, a couple of them have been destroyed, and one of them actually got destroyed by the facility around it, just, like, collapsing because no one cares anymore, which is a shame. Those things should be in museums. But that's just me. But yeah, space debris, that's a thing. And if you like anime or just want to see something that's kind of interesting, it's considered a hard science fiction because it actually tries to keep true to science, the way, you know, science actually is, you know, how things should move in space and all that. But yeah, Planetis, check it out. Space Brothers is also a really good one. Space Brothers is ongoing. Planetis only lasted a season. It was a shorter story. But also interesting is what Planetis talks about. So, we didn't really talk too much about it when we talked about asteroids. But there are some asteroids out there that are laden with rare minerals, right? So, let's see. Let's find the asteroid belt. Something out here. Yeah, sure. Let's go with this one. I don't know what you look like. There we go. See, so this is an asteroid that looks like a potato, unlike the other ones which are more rounded. So I found a jacked one, finally. Now, some asteroids are stony, some are rocky, some of them are heavily mineralized. There's an asteroid that was reported, you know, it's been discovered for a while, but they kind of, I guess, did an analysis of it. They believe there's something like 10,000 quadrillion dollars worth of nickel, iron, and silver on an asteroid. So the economy of the Earth could basically be just completely destroyed if someone were to go out and mine an asteroid. You send some crafts up, they pick some stuff up, they drill through, they fill up a big bucket, bring it back to Earth. Oh look, here's some space metal. It's the same metal we have here, but from space. So extracting it is expensive, but you increase the supply of, let's say, silver. Maybe there's some that have gold. Gold. What happens if you start bringing metals from asteroids back to the Earth? What happens to the economies here on the Earth? What happens to supplies? But more importantly, you know, again, there's debris that you leave behind, things like that. But that brings up the next question is, like, you know, who owns the mineral rights of an asteroid? Is this where commercial spaceflight becomes a thing? If Elon Musk gets there first, does he own the asteroid? Yeah, it would flood the economy with volume, but the cost to produce it is huge. You are correct, right. But as more people start to do it, as spaceflight becomes cheaper and cheaper, it hypothetically would become more viable. If ion engines or, you know, impulse engines, there's, I mean, the EM drive, which may or may not truly work the way as intended, if that becomes a thing, can we fly around and collect minerals and, let's say, you know, go to Titan and collect methane or mine an asteroid? I think the concept of mining asteroids or comets will be more like old derby style of fishing. Okay, sure. But that's actually kind of what I'm circling around with. That is that in the anime Planetes, they actually have a sub-story. So there's the story of the people that are going out to clean up, and that's this dude right here, and the people he works with. This is the cleaning crew, right? There's actually a subplot where there's like a terrorist faction from third world countries that are fighting with the first world countries. Like, they're actually like blowing up spaceships and trying to like sabotage the moon base and all that stuff, because only the rich countries are extracting minerals, and, you know, first world nations are traveling space and collecting minerals and increasing their own wealth, and the third world countries are being left behind. They're not getting anything from it. And so, like, there's like this weird little sub-story of this like terrorist faction trying to bring equality to space travel. So it's an interesting thing. Like, you know, what happens economically is one thing. What happens politically when you've got, you know, let's say the United States does it, or, you know, a private company from the US does it. What if it's a private company from China, or from South Korea, or a Japanese company, or, I don't know, South Africa? You know, whoever gets there first, yeah, it's first come, first serve. But then what does that do politically? What does that do economically? How do things change when this kind of stuff becomes viable? Get as much as you can, as quick as you can, while the window of viability is open. What if it's a state-owned company, not privately? Well, again, that becomes an interesting thing. You know, which nation, you know, our nation's going to start claiming this asteroid is mine, that asteroid is mine? Is it like colonization of the Western world? You know, when Europe began colonizing everything and just kind of claiming countries for themselves? Is that what we're going to do with space? Just start, you know, I claim the following 5 asteroids. You can have those 2. Or is it going to be like a joint thing where, you know, you get coalition government kind of thing, or like the United Nations, but a space thing, almost like the United Federation of Planets? You know, is that a thing? Or it's not a world government, but it's actually a governing body for space travel. Is that a thing? And if so, when does that happen? Who controls that? Where do we base it out of? Like, it's interesting to think about the future. At least that's for me. Like, I love that stuff. I want a Star Trek world where we can travel around space and, you know, life is about study and exploration, not about working 40 hours a week just to be able to put some food in your belly. I mean, that's part of it too. And officers in Star Trek do work, obviously, but a lot of it's provided to them, and their reward is their research and their functioning within the space, within the Federation. So, you know, it's an interesting, strange, quasi-socialistic thing, I guess. I don't know. officers don't work. This is all true. This is also true. You know, there's the shammers, and then there's the NCOs. The NCOs will be doing everything, and you know, officers will be doing jack all. They need to send the red shirts to do red shirt things. Ah, yes, the meat grinder. Got it. See, I'd be a blue shirt, or I guess they were teal shirts for a while, and then they kind of switched things out. But you know, astrophysics. That's what I'm here for. But yeah, that's kind of where things are at. Yeah, well, it's been fun. It has been fun. I hope you enjoyed it. I did see a couple people show up. Didn't get any new followers today. That's okay. I'll be back on Friday to talk about stuff. Look forward to catching it next time. I appreciate you. I always appreciate you showing up, friend. Hopefully we'll have some more people showing up next time. And we'll have more Gedanken experiments, more thought experiments about the future. Hope y'all had a good time. We'll see you on Friday afternoon. Take care of yourselves, each other. See you next time.